Hi, this is Terence Fernandes. Thanks for watching my webinar today. Feel free to join us on youtube.com/viaProtect for more great videos and more webinars. We hope that you'll find those helpful. Thank you.
Hi everyone, this is Terence Fernandes. I'm here today to talk to you about automating network security, and we're going to use viaLab to do this. Just a little bit about myself. I'm a mobile security engineer here at viaForensics. I've mostly been working on the viaLab product, which we think is the most comprehensive mobile application security suite here on the market. I joined the company about 3 years ago, and I worked on other forensics and computer security projects as well. And also I'm originally from France, so if there's some words or some typos in there, please pardon my French. All right, let's get started. For those of you that attended my talk a few weeks ago, we talked about the viaLab architecture already, and this slide may be familiar, but I thought it was interesting to go over this again and focus on the network part of it this time. So just as an overview, viaLab, like I said, is a mobile application suite that has many tools to test the security of your mobile applications on both iOS and the Android platforms. It works by running inside of a VM. It's a software that runs on Sentoku Linux, which is a custom Linux distribution, and that has many tools to test the security of mobile application as well. Open source tool. It's an open source distribution that you can freely download. You connect a couple of devices, like I said, either iOS or Android devices, to the laptop that have your application that you want to test, and then you can run assessment on that. An important point of this diagram here is that the phones connect to a Wi-Fi network that viaLab is actually starting. And we do that so that we can capture all of the network traffic that is being sent by your phone and therefore by your application. And you'll see that this is obviously very important for the different network tests that we're gonna show you today. Let's talk a little bit about the viaLab features, and like I said, we're going to focus on the network analysis today, but that's not the only thing that viaLab can do. viaLab can also look at the file system. Where is your application storing data on the file system, and what's inside the application folder. We take a look at the logs. We have automatic searches, and we'll talk a little bit about that in the next two slides. We also decompile the code, look at different flags and permissions, but like I said, what interests us today is the network analysis. And for that, we do network captures, we do man-in-the-middle, which is a very interesting attack that we'll go into details, explaining what it does, and we also do SSL proxying, which is a derived attack from the man-in-the-middle, but we'll see that there's a major difference between the two. So before we jump into the network test, and again, this slide was shown before, but I thought it was interesting to remind our viewers that when you do an assessment, it's interesting to search for specific values, and viaLab helps you do that. Those values can be, for example, the username, the password that is being used to logging into your application, some keywords, but they can also be patterns, and we call that regular expressions. That can be, for example, credit card numbers, social security numbers, or any patterns that you would like to create. So regular expressions are not a specific value, they're just a pattern that you can match if you find a value in the traffic that would match this pattern. And this is pretty important, like when we're going to see in the network traffic, if you find your credit card number, you don't necessarily want to have a specific value for that. You just want to see if you can find any credit card number passed over the network. So viaLab does that automatically in the background. And one interesting point as well is that we don't just search for the plain text value. We also look for the hashed and the encoded values of the plain text value that you provided us with. viaLab, like I said, is automatically going to find the results and populate that into a tree view. it does that in the background, and you have the ability to add, modify, or even delete the findings or the risk rating if you'd like. And at the end, you have a nice report that has all of those different findings that viaLab found for you or that you added manually. So let's talk a little bit about, let's jump into the networking side of things here. And I wanted to discuss, there's many issues in terms of networking with mobile application, but I wanted to discuss the top three issues that we found commonly in our testing here at VIA Forensics, and that viaLab can help you fix. The first one is using insecure network protocols like regular HTTP. We'll talk a little bit about this, but by default, HTTP is not meant to be secure. The traffic is sent in plain text, and if your application is using HTTP, then you should assume that all of the application traffic can be viewed. So that's definitely a high risk for us. If you're using HTTPS and you are encrypting your traffic that way, you should be aware that it's not necessarily enough. You should be very careful about validating the SSL certificate correctly, and we find that many applications that use SSL and HTTPS, which is a good thing, actually don't validate the certificate, which makes it vulnerable to attacks like man-in-the-middle or SSL proxy attacks. And talking about SSL proxy, even if you validate the certificate, you need to be careful about which certificate you validate, and we'll talk about certificate pinning and how to avoid that issue of trusting this SSL certificate blindly. So let's talk a little bit about the first issue that I mentioned here, which is the insecure transmission of data over HTTP. Like I said, HTTP is not meant to be secure. It's a protocol where all the traffic is sent in plain text, and it's designed that way. The problem with that is that it means that everyone that is sniffing on the network can basically access your application information. By sniffing, I means that you can have a hacker that is on the same Wi-Fi network as your user, and they can actually see the frames and the traffic that way. To do that, you have very simple open source tools like Wireshark or TCP dump, and simple network capture is enough to capture that information and run searches on it. viaLab is actually doing regular network capture, as I said, as one of the features, and we do that so that we can check if the application is using SSL or just a regular HTTP. If your application is using SSL during a regular Wireshark capture, the traffic will be encrypted in that SSL tunnel, which means that we won't be able, during a regular network capture, to view the data. On the other hand, if your application is using HTTP, then we'll be able to view the data in plain text. And you can see here, as an example, this is the AnyDo application, which is a task manager application that uses HTTP for the logging screen. They actually fixed that issue a couple of versions ago, but one of the oldest version was doing this. And you can see that viaLab automatically found that information because I provided my password, and I said, go search in the background to see if my password is in the network traffic. And you can see that the email, the password, were sent over this HTTP frame here. As I mentioned also, we encode and hash those values, and you can see that my username was also found in base 64 in this traffic data. viaLab also helps you to see where your data is going and how it's getting there. So basically, one of the outputs that you're going to get in your report from viaLab is going to be a nice summary of all the different servers that your application talked to, the size of the frame and which protocol was being used. If we see HTTP traffic in there, we're going to automatically give you a finding saying that your traffic is insecure, or at least part of it is. But if you look at this traffic output and summary, then you'll have a nice overview of where your application is going and which protocol it's using to get there, which is a very interesting information to pass along to your developer if you're a developer yourself. For example, we had issues with application where the developer actually coded it right and used SSL properly, but some of the advertising network that they added was not using SSL properly. So be careful about the libraries that you're using, especially in terms of advertising or marketing or analytics, because those are also part of your application at the end and might provide to a hacker some useful information about your users. So this summary is pretty useful to take a look at those issues. Let's talk a little bit about the SSL certificate, and this is being used to validate basically the trust between you and a remote entity. So by remote entity, it's usually a server. The remote server has the certificate installed, and you present it to your browser or the mobile application. There's no real difference in the way that it's being done between your browser and a regular mobile application. So when you see, most people now are familiar with the little padlock that says that it's secure on your browser. This is due to the validation of the certificate. And if you click on it in most browsers, you can actually see some of the details. Who issued it. So this SSL certificate is being issued by a certification authority. We call that a CA, which is basically a trusted company that can issue those and that build that chain of trust that is being used to, like I said, validate that the connection that you're having between you and the remote entity is valid. One thing that I mentioned in the previous slides is that when you send data over HTTPS and SSL TLS, that data is being sent in an encrypted tunnel. So during a regular network capture, if you're using HTTPS and SSL, we won't be able to see the data inside the tunnel. However, there's some attacks like man-in-the-middle and sub-proxy that can defeat that. Just to continue on the SSL certification validation, this is basically a handshake process, and you have a little nice diagram here where the client, so either your mobile application or your browser, basically say hello request to the SSL server. The server replies with the server certificate. We validate that on the client side. You exchange the key. And then there's what we call the change of the cipher spec. So this is basically the server telling you this is what I can accept in terms of ciphers, so in terms of encryptions and protocols, and the client and the server come back and forth to get the best one that would work for both. And then once this is done, the tunnel is created. Like I said, this certificate is signed by a trusted certificate authority. And I say trusted in theory because you'll see that in SSL proxy, for example, we fake being a trusted certificate authority. So you'll see that this is really in theory. And if the signature doesn't match, the signature of the SSL client, of the SSL certificate, doesn't match with what's being sent by the SSL server, or if it's not trusted by a certificate authority, then the certificate is invalid. And we'll see that this certificate being invalid is actually the basis of the man-in-the-middle attack. So man-in-the-middle attack, like its name is describing, is basically putting yourself, or in this case viaLab, in the middle of the traffic between your application and the end server. So we'll see if your application, if you remember this little diagram where the server sends the server back to the client during the handshake process, and the man-in-the-middle process, viaLab is going to be the one sending the certificate. And this certificate is non-trusted and self-signed, which means that it was not signed by a trusted certificate authority. So it is invalid, and we do that on purpose so that we can see if your application is actually validating the certificate that it's receiving, and not blindly accepting any certificate. So if your application is validating the certificate, then the man-in-the-middle attack will fail. The application will see that the certificate is invalid and should not proceed with the creation of the tunnel and sending of the data. This usually happens when your application shows a little pop-up saying, error, network error, or sometimes they're a little bit more verbose than that and tell you that the end server is not trusted. However, if your application is using HTTPS but is not validating the certificate, in this case, our non-trusted self-signed certificate will be accepted by your application, and this time the data that is inside the encrypted tunnel will be available to viaLab. Because it's basically using the certificate that we provided, and we act in the middle, and we are in the middle of this tunnel. So this is a very powerful attack, and a lot of applications out there are vulnerable to this, and we'll talk about how to fix that issue and how to validate the certificate properly. Just before we run to the recommendation, I want to talk about the SSL proxy attack. SSL proxy is similar to the man-in-the-middle attack, except that this time the certificate that we provide is trusted by the phone. And how do we do that basically? Well, we installed a fake certificate authority on the device itself. It requires root to do that, but we want to do that so that we can see if your application, even if it's trusted by the phone, is doing additional checks, and it's called SSL pinning to defeat that. But basically, it's doing additional checks to see if the SSL certificate is actually the one expected by the application. So in this case, it's the same diagram where viaLab is in the middle, but the certificate is trusted by the device. And if your application is not doing SSL pinning or certificate pinning, then we'll see again the encrypted data inside of the tunnel. And every time we do that, we obviously search for information that you provided us. So like I said, the username, the password, any keywords, credit card information, things like that could be useful to a hacker. So this process usually requires you to logging into your application, populate some data during the test to see what we can capture during that network capture, that man-in-the-middle or the SSL proxy test. Well, in viaLab, we thought that this was a little bit repetitive, so we added an automation feature, which basically allows you to create a script where you would do that once. So you would record you going over the data population, the logging process of your application just once, and then use that to run all of those different network tests, as well as some other tests that I mentioned, like static analysis or memory dump, for example. But we'll focus on the network test today. This is pretty important because you can imagine how much time it would save you to run a complete network analysis of your application. You record, like I said, the script once, and then you let viaLab do the rest. So that's a pretty neat feature that allows you to test it even faster. So let's talk a little bit about recommendation, because those tests are pretty scary, and even if we assume that HTTPS and the encrypted tunnel was enough to protect our data, it is obviously not enough if we don't do proper SSL validation or even SSL pinning in this case. So one of the very first recommendation that I would have for every one of us, of you guys that is listening, is to just not use HTTP anymore, unless your data is really not significant in terms of user information, but it's really easy to implement HTTPS and SSL, and proper certificate validation is not hard either. One of the last point that I have in here, but I'll talk right away, is don't copy and code, copy and paste code from Stack Overflow that will allow you to bypass cert validation. You might save a couple of hours or a couple of days in terms of dev for your application and release it faster, but you'll pay the consequences after. This is what we call internal, like the technical debt. Make sure that you do it right the first time, so that you don't have issues along the way, and putting the information of your customers or users at risk. Using certificate pinning is pretty important, and it is the best way to prevent against both man-in-the-middle and SSL proxy attacks. Certificate pinning is basically verifying that the certificate that is presented to you is the right one, and you do that by checking it against some embedded data. And I said from a trusted source. This is usually inside of your source code that you can encrypt as well. So when you're going to receive the certificate, even if it's trusted by the phone, your application is going to run additional checks and verify, for example, the hash of the fingerprint of the certificate or the fingerprint itself, and verify that it's exactly the same one that was embedded statically in the code. So this is the best way of preventing against those attacks. Also, hashing and encoding are not alternatives to encryption, and I would even go one step further, which is encrypt your data even when you assume that you're inside the SSL tunnel. That would be an additional way of preventing your data to be at risk, even if the certificate validation is compromised. Because even if they're inside the tunnel, if your data is encrypted, then it makes the hacker's life even harder. So don't hesitate to do that as well if your data is pretty sensitive. And the last point, but one of the most important as well, would be to capture the network traffic from your application. Run attacks on it, test it, try to play with your application during your development, and tools like viaLab or tools that are open source on Sentoku allow you to do that really easily. A couple of helpful resources that I wanted to mention to help you do that, guys, is the first one is the 42 best practices, which is a very, very nice report. It's not just about network security. It's actually there's actually a recommendation. There are various recommendations about mobile development in general and how to create secure applications. You can go on that link and view them directly from your browser or download a PDF report, and we're constantly adding new content in there. For example, I talk about certificate pinning. I think it's the fifth or the fourth best practice in there that talks about that. We talk about SSL and TLS, how to implement that. And talking about implementation, on top of understanding those attacks, like this was a really quick overview, and there's other factors in there. Those attacks are pretty complex, but on top of understanding them, getting familiar with your network stack of your operating system is pretty important. And I feel like most both platforms that we talk about here, Android and iOS, have very good documentation about that. I put the links in there, and they have pretty good walkthrough in terms of with good examples, especially on the Android side of things, on how to implement your certificate validation in your application correctly. So make sure that you take a look at that, those guidelines, to be able to enforce security standards the right way. A little bit about viaLab, which is, like I said, the tool that we use to do those tests. We have two versions. The viaLab Community Edition was launched recently, and it is a free edition. It allows you to do unlimited testing on both your iOS and Android application, and that includes network capture and automation. So you can create automation script to run regular network captures for your application and see, for example, if there's any HTTP traffic from either your application or additional libraries, like I mentioned, like advertising or analytics libraries that could be putting your users' information at risk. You provision your own devices, or you can even use the Android emulator if you don't want to mess with your own personal devices. You can add your own findings and generate a report like that. This is in the VM that you can download today. It's basically a VM that you just run on VMware or VirtualBox. We have frequently asked questions if you run into any issues during that process, and you'll receive an email with an activation code. You just put that the first time, and then you're good to go. Some of the tests, like man-in-the-middle and SSL proxy, are available in the regular viaLab version, and it has all of the different network tests and attacks that we talked about, and more. There's we talked about at the very beginning of those slides about the different tests that viaLab can run, and I put some of those here again, like code analysis. One attack that you're able to do with viaLab that is related to network tests is the actual ability to run replay attacks. So as you saw in the diagram, when viaLab was in the middle of the traffic, you can actually what we call replay attacks is if you're in the middle and you can change the request of the responses, and since you're the proxy in the middle. So that's pretty powerful if you want to see how your server or your application will react if you modify those frames. There's also dynamic hooking of classes, which is especially useful when you can identify which class is doing SSL checking, and you can try to disable it or modify its behavior. So this is going a step further, but this is definitely a tool that can help you test your application comprehensively. All right, I just wanted to mention that on October 7th, Ted Ewell, who is our VP of Mobile Services, is going to do a video talk about the 5 key considerations for mobile app security testing. He's running with Katie Stremka, the app security team, and they do testing about mobile application. And I'll give you 5 of those 5 advices or key considerations about that. So stay tuned for that talk. And now I guess I'll answer some questions. Let me take a look at the questions that we have in here. All right, the first question, is it possible to know if an application is using insecure network protocols without taking a look at the phone itself? Like I said, if you are snooping in the traffic on the network, you can see if your application, without even taking a look at the phone, you're just another user of the network. You can snoop the network traffic and see if any other application out there on that network is sending information over HTTP. So use Wireshark or TCP dump or of course viaLab and viaLab Community Edition to do this. I have a second question here, and people, if you have any questions, you can feel free to add them in the chat box at the bottom right, of your screen. Are there any big differences between mobile app security on iOS and Android? I would say no. The concepts are the same, and those tests that we talked about today are available for both platforms, for testing on both platforms. Obviously, the implementation of the SSL certification, validation, and checking is different just because those platforms use different programming languages, but the general concept is the same, and both platforms are at risk for those issues here. All right, I think I have one last question that I see here. Is there, if there are 2 applications, one vulnerable and one secure, on a mobile device, does the insecure one still put the secure one at risk? This is a pretty good question, and pretty general in the sense that yes, I would say that if your insecure application is transmitting, for example, the password of your user, most users out there will use the same password and the same credentials for the application. So, or you might find any other piece of information in that insecure traffic that would help you hack into another secure application that you had before on your mobile device. So yes, I would say that if you have an insecure application, you're putting the overall security of your mobile device and all of the other application at risk.
Alright, so that looks like we'll be wrapping up the question section. I just wanted to say thank you to everybody for tuning in. Thank you to Terence for putting this together for us. And we will be having, like he mentioned, our next viaTalk 2 weeks from today at 1 p.m. So you can go ahead and register at viaforensics.com/viatalks. And the video for this webinar will be available on youtube.com/viaprotect. So if you would like to go watch it, you can subscribe. You can just search viaprotect and our channel will come up and you can subscribe and see all of our videos from past webinars, and you will see all of the future ones posted there as well. So give it about 24 to 48 hours before that's uploaded. And other than that, thank you very much. I hope this was useful to everybody. Thank you to Terence, and we hope you all have a good day.